All right, so we have a quiz, Monday, March 4th. All right, so one of the things we're going to have to do on there is similar to this journal. This is going to be new stuff. All right. Um, you have to understand what elements are. You have to understand what compounds are. You have to understand what mixtures are. So Tuesday we went over this worksheet, that classification of matter POGO, which you just got back probably. Um, and when we did this journal, I gave you guys a hint that when you're doing particle models of the different things, it's really just like the front of that worksheet where we did the different shapes. But instead of doing the different shapes, I asked you to do different colored dots. And the reason why is because if you remember from last semester, whenever you did models, you were probably doing dots, right? Dots for particles. All right, so now we can kind of, and what we did was we just made, if you had a particle of water or whatever, you might have just made a blue dot. If you had a particle of anything, you would just make some colored dot, whatever. But now we can kind of differentiate between elements and compounds and different types of mixtures. So we got to be able to do that. So on the worksheet, we had like examples of elements like R, or we had T, or we had SQ2. Those are some examples from your worksheet. And really what it means is with an element, just all of the particles are going to be exactly the same. All the atoms are going to be exactly the same. So a couple different options I could do on that. Maybe I just make some red dots. That's pretty easy. You also saw with SQ2 that sometimes we can have diatomic elements, which means two atoms combined. So maybe I have two atoms stuck together. But still, throughout the whole sample, there's only one type of atom in this box. Okay? So that would still be an element because all of the atoms, all of the individual dots are the same color. All right? With compounds, we're going to have more than one dot. And we're going to stick them together. So maybe I have like a blue dot stuck to a red dot. That would work. And we did something in the packet that said how the dots are joined. What is the thing that's holding them together? Chemical bonds. Okay, so compounds would be two different atoms, two or more different atoms with chemical bonds, so chemically bonded. Okay? Now, if I want to talk about mixtures, now I'm going to have some different types of particles. And in the worksheet, we did say that these compounds, these individual molecules, do count as particles. All right? And so do atoms. So particles are like the number of things. So if I look at this picture, I've got 1, 2, 3, 4, 5, 6 particles. Here I've got 1, 2, 3, 4, 5. Here, 1, 2, 3, 4, 5. Okay, so those number of particles. Understand atoms and molecules are particles. So if I make a mixture, what did I say the first one? Mixture of elements and compounds. So I might do for this, I might just have blue dots representing some element. And then I might have another one that's a compound. Okay. So in a mixture, we're going to have more than one type of particle. We call these things up here, since they only had one type of particle in these, we call those pure substances. All right, making sense so far? Do we know all this already? We're good? And the last one, if I wanted to make a mixture of compounds, I'm just going to make more than one different type of compound. So maybe I'll do the black and red stuck together again. But now instead of being mixed with just blue dots, elements, maybe I'll make like a green and blue compound also. All right, so here we have more than one different type of particle. We have particles that are black and red stuck together. We have particles that are green and blue stuck together. They're all different compounds, so it's a mixture of two compounds. Does that make sense? So the thing was, when we went through this classification of matter POGO, you want to use this as a study tool, because when I make this quiz, which I haven't done yet, if we do all of the numbers 1 through 12, which is what we reviewed the other day, that's what's going to be on this quiz. Okay? There were also some people said to me, hey, can we go over the back page? Which we will. We will talk about that, the separation techniques. But that's the separation techniques, which was also on your worksheet yesterday, is coming up next. So that will not be on the quiz. You're not responsible necessarily for telling me how these would be separated. All right. So that's what the new stuff is going to be. We need to be able to tell if it's a pure substance. Is it a mixture? Is it an element? Is it a compound? Maybe I can give you chemical formulas and say, what is this? So, for example, if I gave you this. So here's some examples. What if I said we have just this? What would you call that? An element, a compound, or a mixture? A compound? What is a compound? Who said an element? Okay, element. Why? Just one thing. It's just one AU. How can we tell it's just one thing? Because there's only one capital letter, okay? So it's just one thing, element. No, because you got to see this. This is going to amaze you. Write it out. What if we had this? What do you think that would be? Element, compound, or mixture? Why an element? One capital letter, right? Just it's still one thing, all right? So it's still one type of atom. The only type of atom we have is F, fluorine. There's only one type of atom, again, element. What if you saw something like this? Mixture, why? Okay, so we have this thing, whatever this is, and we have this thing, whatever this is. The and sign, as we learned from the POGO, helps us understand it's a mixture of two different things. Okay? So whenever we see that and sign between two things, we're going to be thinking mixture. And you can probably guess this one before I even do it. What is it? Compound. Why? More than one type of atom. You're right. If there's a capital letter here, every time I see a capital letter, I know that's a certain atom. Okay? So I have H atoms, I have O atoms. They're stuck together. There's no and sign. So therefore, it's a compound. All right? And make sure if you study that POGO that you look at the little parts they put in between where they tell you definitions, things I told you to mark on there, like matter is classified as a pure substance when all the particles are identical. Matter is classified as a mixture. Study this up through number 12. So just back page you're not responsible for on a quiz yet. All right. Now you have your old quizzes. I want to talk about those because here's what we're going to do. I'm going to give you that stuff again. All right. Some of you did very well. Some of you not so great. So we want to try to improve that. So we've got the classification of matter POGO. We're going to study that. And we're also going to study the last quiz. Now, I'm not going to do the graphing on the front again, but the other stuff I am. Okay? The graphing, there were still some problems with scale, still some problems trying to determine slope. Slope being the relationship between the two variables. But if you've got your last quiz, go ahead and go to the second page. Yeah. Okay, so I know everybody loved this paragraph that I put in there with all the blanks. Everybody was super happy about that. But you can make those corrections because you're going to have the exact same paragraph again on this quiz. So it should make it super simple. And a bunch of free points. Or easy points, I should say. So here's how it goes. At point A, the beginning of observations, the substance exists in a solid state. Material in this phase has blank volume and blank shape. So the thing with solids is no matter what the container, the shape is always going to stay the same. No matter what the container that we put the solid into, it's still going to take up the same amount of space. So the way we put that is we say it's a definite volume and definite shape. All right. The third blank. With each passing minute, blank is added to the substance. So as we go along to the right, some people put heat. I was actually just looking for energy is added. If you put heat, though, I didn't mark it wrong. Like I said, you're going to put your own words. Sometimes there's not just one right or wrong answer. Some people put like constant. for the volume and shape thing. Then I put that was okay. But energy is added to the substance. This causes the molecules of the substance to blank more rapidly. That would be move more rapidly, right? So when they get more energy, they move faster. Usually, this causes the molecules of the substance to move more rapidly. We can say move more rapidly because we detect it by lot of people miss this one. The fifth blank is temperature rise. Okay, remember that temperature is related to the average kinetic energy. Temperature is directly related to the speed of the particles. Okay, so whenever the temperature is changing, the speed of the particles is changing, either getting faster or slower. All right, the next blank. At point B, the temperature of the substance is blank degrees Celsius. So all we got to do is look at point B, go to the left, and that would be 70 degrees. All right. The solid begins to do what? What does it do at this first plateau? Starts to melt. All right. The solid begins to melt. At point C, the substance is completely melted. Some people put like is completely liquid. That works actually. Kind of makes 9 weird though, because then 9 says, or in a blank state. It's completely melted or in a liquid state. Cool? All right. Time. Too bad Gabriel took up the whole first half hour. All right. 10th blank. Material in this phase has. Okay, so if we take a liquid and put it into a different container, does the volume, the amount of space the liquid take, does that change? No, it still takes up the same amount of space. So when we say the volume won't change regardless of the container, we say it has definite volume. Will its shape change though? Yeah, it'll take the shape of the container. So we say indefinite or not definite, whatever you're more comfortable with. People who put no shape, I didn't mark that wrong. But if you put no volume, I marked that wrong because that doesn't make sense. Even if you put that for gas, no volume, it still has volume. It's just volume of the container. All right, so we are at, which one here? The energy put to the substance between minutes 5 and 9 was used to convert the substance from a solid to a liquid. Okay, so the 12th blank is solid, 13th blank is liquid. This heat energy is called the latent heat of fusion. Latent heat of fusion, an interesting fact. Between 9 and 13, the temperature is changing. The temperature is increasing. I noticed that on the graph. The added energy increases the temperature. Right, we see the temperature going up. Okay. During the time from point D to E, the liquid is doing what? Vaporizing or boiling. Either one would work. By point E, the substance is completely in what phase? Gas. All right. Material in this phase has blank volume and blank shape. Okay. All right, so this would be the shape and volume just depend on the container, right? So both of those should be indefinite. All right, here we go. So the energy put to the substance between minutes 13 and 18 converted the substance from a liquid to a gas. All right. This heat energy is called the latent heat of vaporization. An interesting fact. Beyond point E, the substance is still in the blank phase, gas. All right, but the molecules are moving faster as indicated by the increasing temperature. Again, if the temperature is going up, the particles are moving faster. All right, conservation of energy. All right, conservation of energy means that energy, not matter by the way, some people automatically thought matter, but energy cannot be created nor destroyed. Okay, so the last part is the LOL charts. All right, so we've got a chart looks like this. Something like that. There should be a circle in the middle. We have a couple of different types of energy that we're talking about here. We have thermal energy and we have phase energy. Okay. Energy thermal, energy phase. Now, you do have to know what we use as norms in the class. You do have to know that we use one block when it's a solid. We use two blocks when it's liquid. And 4 blocks gas. All right, you do need to know that. So the first thing we got to do is identify what is the system. What is the thing that we're focused on? Okay. And so in this question for number 4, it says fill out the following LOL chart to describe the water vapor in the air condensing during the night. So first of all, we got to have that. That was one of the points. You got to have the right system, water vapor. All right. Now what I recommend is right after that, go to the phases. So what are the phases for the water vapor at the start and at the finish? The left side, this is my initial part. So this means at the beginning, before the change. And then we have the final part over here, which is after the change. So just do the phase change first. What was it to start with? Was it a solid, a liquid, or a gas? It was a gas. It said water vapor, right? So if it's a gas under phase, we're going to put 4 blocks. Okay? Because this is our norm. I'll make them all the same. All right? What is it at the end? Is it still a gas at the end? Is it a solid? Is it a liquid? How many blocks for a liquid? So under phase, I'm going to put 2. Liquids are 2, right? What about the thermal energy? So the thermal energy is like the temperature. Okay, phase energy is just the energy involved with changing the spacing or the arrangement of particles. Okay? Thermal energy is like the temperature. So is the temperature changing from the beginning of night till morning? Okay, so would you say it was maybe a little warmer at the beginning? So all I was looking at here was that your thermal energy went down. For phase energy, I looked at the exact number of blocks. But thermal energy, I just made sure that you had more blocks at the beginning than you had at the end. Okay, maybe I put 1 at the end. All right, and the last part, count the number of blocks on each side. So here I have 7 blocks over here. I only have 3 blocks here. So what's the change? How do I go from 7 to 3? I have to lose 4 blocks. So if I lose 4 blocks, that means 4 blocks go out from the system. All right, and then that's all for the chart. You could put a Q there symbolizing the heat transfer. Energy is heat. Now, the process. So for process, maybe it's my fault for not being clear, but what I'm looking for now is endothermic or exothermic. What is it called if the energy is leaving the system? Exothermic. Okay, so that was the process for 2 points. Got one more part to put on this video, so you might want to watch it, Owen, at home. Okay. All right, so 6. A lot of people struggle with 6, and here's why. I'm not going to do number 7. It's just like what we did here. But you're going to find that when we melt candle wax, the phase is going to go from 1 block solid to 2 blocks liquid. The thermal energy is going to increase, so maybe you went from 2 blocks to 3 blocks or 4 blocks or whatever. And energy is going into the system in order for that change to happen. So on number 7, it's going to be endothermic for the process. Now, number 6, I was looking for 4 things. I wanted you to talk about the thermal energy, which that's the temperature, that's the speed of the particles. So what happens to the speed? What happens to the speed of the particles? Do they go faster or slower? In the first example, where we talked about the water vapor, they're going slower, right? So talk about the particles moving slower. Talk about the phase energy, okay? Or phase energy, talk about the arrangement of the particles, which means particles in this case getting closer together. And the last part was just talking about the transfer of energy. So we had water vapor particles. How do particles transfer energy? You got to have something about colliding or collisions. Water vapor particles collide with other particles. And talk about the transfer. That's the 4th thing. So if they transfer energy to other particles, it makes sense that they would now have less energy. Okay? Those are the 4 things I was looking for. Think about the thermal energy, the temperature, the speed. So describe the temperature and speed of the particles, or temperature or speed. The phase energy, the arrangement of particles, how is that changing? And talk about collisions and which way the energy is being transferred in those collisions. And that's all.